the angle that we would be looking for, and I'm just going to call it x. Okay, one of the things to keep in mind in dealing with the law of cosines, one, you don't have to memorize it ever. So even if I give you a test on it that I don't allow you to use notes on, I'll always provide the law of cosines. I'll provide it in this form. Okay, it'll be an adjustment from the Pythagorean theorem. So c squared is equal to a squared plus b squared, and the adjustment is minus twice the product of those sides a and b times the cosine of the angle opposite this side that's alone on the left side. Okay. The thing to keep in mind with this, again, you don't have to memorize the equation, but you have to understand how to use it. And one of these two outer pieces of information, one of the c values is going to be your unknown. One of those is what you're solving for. And then whatever is opposite your unknown, whatever is opposite what you're solving for, will be placed in the other c spot. So we're solving for an unknown angle. So we're going to replace this c with x, which means the value that we need to start with and isolate on the left side of this equation is what value? Opposite this unknown is 6.8. So the way that you would set this equation up is 6.8 squared is equal to the sum of the squares of the other two sides minus twice the product of those two sides, all times the cosine of, and I'm going to call that, again, we replace that with the unknown angle, in this case, x. Okay. So if you're going to use your calculators to solve this, okay, and you enter it in this form, it gives you symbols that don't make sense. Okay. Your calculator cannot perform the inverse trig ratio on this variable built within the calculation of the solve feature. So what you have to do is what? So, good. What you're going to do is you're going to take this whole expression, replace it with x, and then you're basically just going to solve for that cosine ratio. So again, you just need to organize that mentally, because when you calculate this through, if we enter this in our calculator, so under the algebra tab, the solve feature, we can type in our equation just as it appears. 6.8 squared is equal to 7.1 squared plus 9.2 squared, all minus 2 times 7.1 times 9.2 times x. And again, not cosine of x, just times x. Identify using a comma what variable you want to solve for. So we'll put comma x to tell us we want the calculator to compute the solution for that variable. Close it off with a parentheses, and now we can look to see I've entered numbers with decimals, so my answer will be in decimal form. If it wasn't, then I might need to hit the green diamond button to get the decimal form for my answers. But when I hit enter, I get that x is equal to 0.6798 approximately. And now remember, what was x actually used for? X was substituted in for cosine of x. So here's really what I'm calculating. And so using this form, anytime you need to know an unknown angle, if you're given the ratio, you're going to use the inverse function. So I'm going to take the inverse cosine of that ratio, and that's going to give me my angle measure. So now I have it written right up here. If I take the inverse cosine, highlight this, and I hit enter, close off the parentheses and hit enter, you don't even need to erase the x equals on this. You can just hit enter. The only difference is it gives you an answer in an equation form, but that's still the correct answer. So angle x is 47.2 degrees approximately. So this is as far as you would have to go on the problem like the quiz. And let me go back and go through just a couple things that could possibly save you time based on what I saw happen quite a bit. And one of the things that I noticed happening is, so you get your solution for the ratio, and then you want to take the inverse cosine of that. Okay, what a lot of you did was, right after you entered this, you then moved all the way down to the x equals, which again, I just showed you you don't need to do, but you deleted that, And then where did you have to go after this? All the way back to do what? Yeah, to close off the parentheses, right? Okay, so because of that, the easiest thing to do is if you just hit your inverse cosine, okay, highlight this. Before you, if you are going to delete the x equals, close off your parentheses first. Again, it just saves you a little bit of time, and as you guys had even commented today, okay, the 10 minutes is a short amount of time to do that. So by going through that step, it does save you a little bit of time. You don't. The time that I would take the time to delete it like this if, one, if you're using the computer TI emulator, because you can't copy and paste on that. With the handheld ones, you can go in and copy and paste just what you needed, and leave out the x equals. But if I had asked you in this problem to solve all the remaining angles, then you would probably want to do that because now you'll need to refer to this 47.17 again at some point. So having that be accessible for the other calculations might be useful. Okay, so actually let's talk about that. What if I asked you to find all of the angles for this? Okay. What options do you have to find the missing angles here? Let's say I call these angle Y and angle Z. Say. Okay, so you can do the law of sines because right now we have 3 sides and an angle. So if we use law of sines, the pattern we're using is SSA. Okay, so the advantage to doing law of sines on this is it's an easier calculation, right? I mentioned before. On the quiz, 70-something% got the law of sines question right, but only 37% got the law of cosines question right. So the law of sines is an easier calculation for you guys. The disadvantage to it is when you're using SSA pattern for law of sines, how many possible triangles might you have? It's possible that you have 2 triangles, right? So by using law of sines, it may be the case where you find the wrong angle measure if you don't check it or you don't use the correct methods for it. Okay. Now, in addition to using SSA and law of sines, you could also use law of cosines again, right? We still have SSS. So we could find angle Z by setting it up as 9.2 squared is equal to the sum of the squares of the other 2 sides minus twice the product of those times the cosine of Z. We could do the same calculation that we did here, but for the 9.2 instead. Okay. Again, the advantage to that is the law of cosines will always give you the accurate answer. Okay. The disadvantage is the law of cosines is a more complicated calculation. Okay, so it's up to you to determine what you want. Okay, now, here would be my suggestion if you're going to use law of sines. Okay, so if you use law of sines, the problem on law of sines comes when your unknown angle is an obtuse angle, right? The angle that you're solving for is obtuse angle, because that's the one where using unit circle, again, you guys will learn that later, but the unit circle starts to repeat the sine ratios once it gets from 90 to 180 degrees. And so when you're looking at that, if you look at these 2 angles, Y and Z, which one has the potential for being an obtuse angle? YZ. Yeah, because it's opposite this longest side, right? Is there any chance that Y could be an obtuse angle? There's no chance. So if you use the law of sines and find angle Y, are you guaranteed to find that it'll be the correct answer? Yeah. So do you guys see that? If you don't understand what I was just saying, use law of cosines to find a second angle. But if you understand how to distinguish, well, we know that Z is opposite the longer side. So it's possible that we know this has to be the largest angle. So it might be obtuse. We don't know for sure, but it might be. But angle Y is opposite the middle length side. So we know it's a middle angle measure, and only one angle in a triangle could possibly be obtuse. So we know for certainty that Y cannot be obtuse. So what I would do if I needed to find the remaining angles on this is I would solve for Y using law of sines. And so to do that, we would take the sine of Y over the side opposite it and set that equal to the known ratio. So the known ratio, the only angle we have, is this angle of 47.2, and that's opposite a side of 6.8. And so if I was solving for this, I'm just going to multiply both sides of this equation by 7.1. That allows me to cancel here, and I get my sine ratio to be, and now here's where deleting the x equals in my calculation will save me time or make up the time that was lost. So if I take the sine of this 47 degrees, again, anytime you do a calculation, you need to use the exact value, not an approximation. And then we can multiply that by 7.1, and then we can divide that whole thing by 6.8. And that's going to give us our sine ratio, 0.766 approximately. And so to find the sine, or to find the actual angle measure, we'll take the inverse ratio of that value. So the inverse sine of 0.766, calculate. And when we do, we get about 50 degrees. And it's 49.97. That would round up to 50.0. So our y value is about 50. Okay, and so now if I add this angle to our original angle of 47, take that whole thing and subtract it from 180, I get this remaining angle of 82 point. Now, what do you notice here? You would round this to a 9, right? What happens when you look at all these angle measures? They're slightly off, right? Just because we rounded to the 1 decimal. Anytime I ask you to complete all of these, I'll give a little bit of leeway on those calculations to account for that. My